All right, my last segment of the circle calculation video got interrupted. I lost power, so I've started with a new sketch where I've actually done some measurements. Let's say that we're interested in this segment right here, the area of this segment. Well, I created this to be an equilateral triangle in here so that my segment is cut off by a chord that is 4 centimeters long in a circle whose radius is also 4 centimeters. Now I had to pick some measurements, right? Well, if this is 4 centimeters, that's the radius, this is also the radius. We know that this is 4 centimeters, and we have an equilateral triangle because all 3 sides are the same measure. If we have an equilateral triangle, that means that this angle is going to be 60 degrees. So, if I am interested in the area of this segment right here, I'm going to start by figuring the area of the entire circle. Now, a circle area, like we said, is pi r squared. In this case, my radius is 16. Oh, my radius is 4, so the area is going to be 16 pi. I got ahead of myself. So r squared would be 16. The area of the entire circle is 16 pi. That's the whole circle. What about the area of this sector that I have identified? Well, this particular sector has a central angle of 60 degrees out of a total circle 360. So I'm interested in 60 out of 360ths of the entire circle area. So this is the sector, that central angle of my sector that I'm interested in. Well, this reduces to 1/6, so that's 16 over 6 pi, which would be 8/3 pi if I want to be exact. Now we can change this to an estimate here in a minute, but it's always nice to keep your numbers exact as long as you can until it starts to get cumbersome. So the area of this entire sector is 8/3 pi. Let's think about what the area of this triangle would be. I know that the area of a triangle is 1/2 base times height. And for this particular triangle, to figure out base and height, well, there's our perpendicular. If this is equilateral, then this is going to cut this side in half. This would be 2, this is 4. So right triangle right here, I've got a base of 2, a height of hypotenuse of 4. I don't know what this leg is. If I can figure out this leg, then I'll have the height of the entire triangle. And I can use 4 as my base, and I need this height. So let's go ahead and look there. 1/2, 4 is my base, and we're working on the height. Well, right triangle, Pythagorean theorem, a squared plus b squared equals c squared. We don't know a, but we know that b is 2, so 2 squared equals 4 squared. So I've got a squared equals 16 minus 4, because I need to move that 2 square over. So a is going to be the square root of 12, which would be 2 square roots of 3 if I simplify that. So my height here is 2 square roots of 3. So 2 square root 3. Well, 1/2 of 4 is 2. 2 times 2 is 4. So 4 square roots of 3 is the area of the triangle. To figure out the area of the segment, that's what I'm interested in, the area of that segment, I take the sector area and I subtract the triangle. Well, my sector area up here was 8/3 pi. And the triangle area is 4 square roots of 3. And when I take the area of this entire sector, subtract out the area of the triangle, I've got the area of this little segment right here. So now's the time I'm going to go ahead and pull out my calculator and get some calculations done. 8/3, so 8 divided by 3 times pi minus 4 square roots of 3. So minus 4 square root 3. I get 6.645, and then it keeps going. So the area of my sector is going to be about 6.6 centimeters square. So that is this area right here. That's that little piece that I needed to know the calculation for, either because I need to add it into my shape because I didn't have an entire half circle, or because I had something that overlapped and I need to not count this area twice. So very basically, you start with the area of the sector, subtract the area of the triangle, and it's the area of the segment that's left.